All right, so question number 5 reads, how do you graph y equals x squared? All right, so the technique that I like to use is to find some testing points. In this case, we have a parabola here, and once we find the testing points, we can graph out those testing points, and we can extrapolate the behavior of the function from there. Okay, so let's do some testing points here. All right, so why don't we test out? Let's make a table first. Okay, so x and y, and our function here is f of x, or y equals to x squared. Okay, so we're going to plug in some values of x, and we're going to calculate what y is. Okay, so we plug in -3, right? So the square root of -3 is 9. So if we plug in -2, the square root of -2 is 4. If we plug in the square root of -1, it's equals to 1. If we plug in 0, we see here that the square root of 0 is 0. We plug in 1, the square root of 1 is 1, 2, 4, 3, 9. So by doing these testing points, we are now able to plot this on our graph and to graph out these testing points. And by doing so, we can extrapolate the behavior of this function and we can see what we're looking at, okay? All right, so let's draw out our axis here. All right, let me just zoom out. All right, okay, so I don't know if you guys can see these values, but if you can't, you guys can follow here. All right, so first thing that I'm going to do is going to label your axis. Always label your axes, all right? Let me make these a bigger sized, okay? Okay, so this is pretty, so x and y, all right? X and y axis, okay? So we're going to label out our points now, okay? So we have, I'm going to be pretty big with this, so it's -1, -2, and -3. Okay, this is not to scale, sorry, but 2 and 3, okay? So now we're going to label out our other points. So I'm going to put 9 here. I'll put like 1 like here. And it's not to scale either. I'm sorry about that. 0 is over here. I want to put like 4 in between, like right there. Okay, so now that we have our axis and we labeled out the scale of our axes, we're going now to graph our function here. Okay, so we have 0, 0, right? We have -1 and 1. We have 1 and 1. We have 2 and 4. 2 and 4, and we have -3 and 9, and 3 and 9. Okay. So now from here, we're going to graph out our parabola. Sorry. Oh. Okay. Let me just try to connect these dots. Okay. Cool. So this is equal to y equals x squared. As you see here, that as we had some testing points, we can extrapolate what the next points are going to be. So if we plugged in 4, it's going to be 16. If we plugged in -4, it's going to be 16. So we see that it's a symmetrical function, right? From there, we can also know that we see that our vertex, or our minimum value here, is 0, 0, right? There's no value of y that is less than 0, right? In our testing points here, we tested both sides of the axes. Another important fact is that our y's are always positive, and this is because of the nature of y equals x squared, right? So by doing these testing points, we can come to conclusions about our function. We have a symmetrical function. We have a function that outputs only positive values. We know that the minimum is, or the vertex is 0, 0. We know that the behavior of our function, looking at if we increase x, that y also increases. So we have all this different information from using these test points. Okay, so using test points is actually very good as a beginning step towards graphing functions. But once you start to understand the basic functions of the exponential functions, of the logarithmic functions, and how different constants affect them, you don't really need to use these test points anymore. For example, the parabola and the quadratic function is a very good example of this. You'll soon learn that the coefficients of the quadratic function, so our basic quadratic function is actually y equals ax squared plus bx plus c. That these coefficients all mean different things, and they help us to graph out our function without using test points. For example, the coefficient of a helps us to understand how much we scale our parabola by, and the sine of a helps us to understand whether this parabola is concave up or concave down. C, for example, tells us where the y-intercept is, and where the parabola intercepts the y axis. And by using a combination of these coefficients, we can understand where the vertex is, where the zeros are, and a lot more information. By doing so, we can graph them without using testing points. So I would suggest using testing points if you're a beginner and you're trying to understand how to graph functions. But after a while, you can learn what the different coefficients mean and how they affect the graph and how they affect how the graph functions or how the graph behaves. But other than that, the solution is correct and we can move on. Okay, so let's talk about question number 6.